Welcome back to the deep dive. You know, navigating the world of programming, especially Python, can feel like sailing a huge ocean of information.
It definitely can.
And you absolutely need the right tools, the right compass, right? Today, we're looking at some of the most fundamental tools in Python functions.
Ah, yes, the building blocks. You really can't do much without them.
Exactly. So our mission for this deep dive is really to map out the landscape of Python functions. We're thinking about them in like three main groups.
Okay.
You've got the built-in ones that are always there, the ones you actually write yourself, and then this whole universe of functions you get from libraries and modules.
That's a really useful way to categorize them, I think.
Yeah, we're drawing on a pretty comprehensive overview of how Python sets this all up. And understanding these categories, it's kind of a shortcut,
Mm.
to getting a real grip on Python's power.
It really is. Because it's not just about memorizing function names, it's about understanding the why.
Hmm.
Why is this function built in? Why would I need to define my own? When should I look for a library? It pushes you to think more strategically about solving problems, about where the best tool actually lives. It makes learning less daunting, more systematic.
That's a great point. Thinking in these three categories gives you a mental model.
Mm.
You hit a problem, and you can quickly ask, okay, is this a job for a basic tool, something always ready?
Mm-hmm.
Or do I need to, like, custom build something here?
Yeah.
Or, wait, is there probably a super specialized tool someone else already made perfect for this?
Exactly. It builds confidence and efficiency. You're not just randomly searching, you have a framework.
Yeah.
And it reflects Python's whole philosophy, right?
Mhm.
Immediate utility with the built-ins, flexibility with user-defined functions, and then this incredible power through the ecosystem. It's like having, I don't know,
Like a workshop.
yeah, a basic toolkit, a custom fabrication setup, and access to like a global parts warehouse all in one.
Okay, let's start with that basic toolkit then. Pillar one,
Yeah.
built-in functions. These are the essentials, right? Always there, no import needed. Your standard issue gear.
Absolutely. They're the bedrock. They handle the really common fundamental tasks you find in almost any program.
Yeah.
Things you do over and over.
And knowing them well just speeds things up incredibly.
Oh, definitely. Seasoned developers lean on these constantly. Newcomers sometimes overlook how powerful simple things can be.
Like type conversion. This is huge in Python because it's dynamically typed. You don't always declare types. But man, sometimes you really need your data in the right format.
Right. So you've got int, float, stry list, bool. They're crucial for coercing data.
Like user input, right? Always comes in as a string if you want to do math with it.
You absolutely need int or float. It's fundamental for data integrity. You can't add numbers if one's still text.
Makes sense. And then for basic mathematical operations, beyond just plus and minus.
Well, you've got abs for absolute value. Min and max are super handy for finding the smallest or largest item in a sequence. Sum for adding things up quickly. And here's a neat one you mentioned earlier, divmod. It's often overlooked, but it's quite elegant. It gives you both the quotient and the remainder from a division in one go.
Oh, right. I can see that being useful. Like for calculating pages or something.
Exactly. Or time calculations. Anywhere you need both parts. Super efficient.
Cool. And of course, the absolute basics for input-output,
Hmm?
print, and input. Can't do much interactive stuff without those.
The eyes and mouth of your program, essentially.
Yeah.
Basic interaction, getting feedback, essential.
Okay, now this next category sounds really interesting. Object inspection and manipulation, giving you X-ray vision.
Huh. Yeah, something like that. Lena tells you how long something is, like a list or string.
Simple enough.
Tells you, well, the type of any object. Is it an integer, a string, a custom class?
Crucial for debugging, I bet.
Totally. And id gives you this unique number. It's memory address, basically. Helps understand if two variables point to the same object.
Okay. And you mentioned dir earlier, like getting an object's resume.
Pretty much. You call dir on an object, and it lists out all the methods and attributes available for that object. It's like asking it, hey, what can you do?
Wow, that's incredibly useful, especially if you're exploring a new library or someone else's code.
Oh, yeah. Indispensable for interactive work. And related to that is callable. Sometimes you have a variable. Is it just data, or can you call it like a function?
Yeah.
Callable tells you returns true or false.
Okay, that helps clarify things.
And then there's instance. Really important for checking if an object is, well, an instance of a particular class or even a class that inherits from it. Great for robust type checking in bigger applications.
Right, makes sense. What about working with collections, iteration and generators?
Key area. Yeah.
Yeah.
Enumerate is a huge favorite. If you're looping through a list and you need both the item and its index.
You don't need a separate counter variable.
Exactly. Enumerate gives you pairs, index, item, much cleaner, more Pythonic.
I like that.
Then you have map. It takes a function and applies it to every single item in an iterable, like a little assembly line.
Transforming everything into lists.
And filter does the opposite, kind of. It uses a function to test each item and keeps only the ones that return true. Lets you select things based on a condition.
Okay, map transforms, filter selects.
You got it. And of course, range, which just generates sequences of numbers. It's the engine behind most for loops you see.
Sure.
Now, map and filter are powerful, but often, for simpler stuff, list comprehensions are actually more readable and often preferred. Knowing when to use which is part of gaining experience.
Good tip. Okay, any other handy built-ins in this other utilities category?
Oh yeah, help is amazing. Type help in your Python prompt or help some function, and you get documentation right there.
Instant docs. Nice. Any and all. These check if any item in an iterable is true or if all items are true. Super fast for quick checks.
Like validating data.
Perfect for that.
Mhm.
Then you have things like Seach and ORD for converting between characters and their Unicode numbers.
Yeah.
Hex, oct, bin for different number bases.
And sorted and reversed for organizing sequences without changing the original. It's a really solid toolkit you get right out of the box.
It really is comprehensive when you list it out like that.
And they're optimized, reliable. The key isn't just knowing they exist, but recognizing when they are the best, most Pythonic solution. Often saves code, prevents bugs.
Okay, so that covers the essentials that are always there. Let's shift to pillar 2, user-defined functions. This is where we get creative, right? We become the architects.
Exactly. This is where the def keyword comes in. You're defining your own reusable blocks of code. This is fundamental for breaking down big problems.
Reusability, modularity, makes code easier to manage.
Absolutely. Imagine a big program without functions, just one giant script. Impossible to maintain or debug. Functions let you package up logic.
Okay, let's make that concrete. Say you're building an e-commerce site and you constantly need to figure out sales tax. Rates differ, rounding rules differ.
Right, you wouldn't want to copy-paste that logic everywhere.
No way. So you define a function. Maybe something like, def calculates sales tax, amount, tax rate percent, country code US.
Perfect. And inside that function, you'd put all the logic. You check the inputs, maybe?
Yeah, like if not, it's instance, amount, int, float. Make sure it's a number.
Good idea. Check the tax rate is valid between 0 and 100.
Right. Then do the calculation. Tax amount, tax rate, 8%, 100.
And then handle the country-specific rounding, maybe using that country code parameter.
So like if country code equals US,
Yeah.
return round, tax amount 2, else maybe different rounding for Canada or somewhere else.
Exactly. And then you just call that function whenever you need it. Total tax, calculate sales tax, and 108.5.
And you get a consistent, correct result every time just by calling that name. The complexity is hidden inside.
That's the power. Reusable, robust, easier to test and debug. If the tax law changes, you change it in one place, inside that function. And adding that doc string, like calculate sales tax, is crucial for explaining what it does. Self-documentation.
Makes perfect sense. Okay, so we have built-ins, we have our own custom functions. What's the third pillar?
This is where Python really takes off. Functions from modules and libraries. This is about tapping into the huge ecosystem beyond the basics.
The standard library and third-party packages?
Precisely. Python comes with a rich standard library modules included with Python itself. And then there's this vast world of external libraries you can install. It extends Python's power massively.
So you don't have to reinvent the wheel for, like, complex math or working with dates.
Almost never. There's probably a well-tested, optimized function already waiting for you. It's about leveraging the community's work.
Okay, give us some examples from the standard library modules.
Sure. The math module is a classic. Need a square root, math.sqrt, trigonometry.math.syn, math.cos, logarithms.math.log, even constants like math.pi.
Essential for anything scientific or engineering related?
Definitely. Or the random module. Need random numbers. Random.random. Pick a random item from a list. Random.choice. Shuffle a list.random.shuffle. Super useful for games, simulations, testing.
I've used that one. What about dates and times? That always seems tricky.
The datetime module handles that beautifully. Datetime.now gets the current date and time. Stroptime lets you parse dates from strings, like if you read a date from a file.
Oh, that's handy.
And stroptime formats a datetime object back into a string exactly how you want it. It handles time zones, daylight saving, all the messy stuff.
Wow, okay, that's powerful. And interacting with the OS, like files and directories.
That's the OS module. Want to see what files are in a folder on os.lister, a delete, a call.os.remove. A really important one is os.path.join for putting file paths together correctly, no matter if you're on Windows, Mac, or Linux.
Crucial for writing portable scripts.
Absolutely. These standard library modules cover a huge range of common tasks.
And then there are the external libraries. This is where things get really specialized.
Yeah, this is the universe beyond the standard install. Think of giants like NumPy. If you're doing serious number crunching, especially with large arrays or matrices, Python lists are too slow. NumPy's numpy.array is incredibly fast.
The foundation of data science in Python, right?
Pretty much. And Pandas, built on NumPy, gives you pandas.dataframe. It's like having spreadsheets on steroids inside Python. Amazing for cleaning, manipulating, analyzing tabular data.
I hear about pandas all the time.
And for making charts and graphs, matplotlib. It's matplotlib.pyplot.function is the starting point for creating all sorts of visualizations.
So NumPy for numbers, pandas for data tables, matplotlib for plots.
And that's just scratching the surface. There are libraries for web development, machine learning, image processing, networking, you name it. These external libraries let you tackle incredibly complex problems by building on expert work.
Okay, wow. So we've journeyed through these three pillars: the ready-to-go built-ins, our own custom dev functions, and this huge world of modules and libraries. Let's bring it back to the listener. Why does understanding this categorization actually help you when you sit down to code?
Well, like we touched on earlier, it gives you that strategic framework. You encounter a task. Your first thought becomes, is this super basic, built-in territory?
Right, like getting the length of a string. Done.
Or is it specific to my project's logic, something I'll need repeatedly? Okay, time to def my own function.
Like our calculate sales tax example.
Or is this a complex, common problem like advanced math, data analysis, web requests? Then you think, there's probably a library for this.
So it guides your search, helps you decide where to even look for the solution.
Exactly.
Yeah.
It prevents that feeling of being overwhelmed by the sheer number of functions out there. It structures your thinking, leading to better decisions about code efficiency, readability, and using the right tool for the job.
That really clarifies things. It's not just knowing functions, but knowing their place in the ecosystem. So we've covered the essentials always on hand, the power of crafting your own tools, and the vast potential in libraries. Functions really are the verbs, the action words of your Python code.
Couldn't have said it better myself.
So as we wrap up this deep dive, here's something to think about. How might really grasping these different categories built in, user-defined library functions change how you tackle your next coding challenge? Could it give you more clarity, more confidence, knowing exactly where to find the right kind of tool?
Something to ponder.
That's it for us today. We hope you feel better equipped to navigate and utilize Python's powerful functional landscape.